So in this section, we're looking at HL. It's our fifth congruence criterion, our fifth way to prove triangles are congruent. We've already talked about side, 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 angle, side, angle, side, angle, and angle, angle, side. And you'll probably notice that this one doesn't use A's and S's. It's hypotenuse for H, and then L is leg. So in order for us to have a hypotenuse and a leg, we're going to have a right triangle. So this only works with right triangles if they've got a little 90-degree angle in them. So by the end of class, you'll be able to explain and apply the criteria for HL and prove. You need to know this because, same reason we've said all the other times, triangles are one of the basic shapes, a part of pretty much every shape. So if you can work with a triangle, you can work with a lot of other things. And you know you get it when you can use it, when you can use HL. Identify what you need. So, like we mentioned, the first thing that you need is right triangles. They have to be right triangles. So there is two types of right triangles. You could have an isosceles right triangle where the two legs are congruent to each other. We talked about isosceles in the last lesson. Or you can have a scalene where none of the sides are the same. None of the sides are the same. Isosceles, we got the two. Now, think back to our last lesson. Ask yourself, could you have an equilateral right triangle? And no, because we talked about equilateral triangles, all three angles have to be 60, so you can't have a 90 in there, because then you wouldn't have 60s. So, cannot have an equilateral right triangle. But you can have isosceles, you can also have a scalene. If you did have an isosceles right triangle, these would be the two legs, which means these would be the base angles. And you know that base angles always have to be the same. So if this is a 90-degree angle, another thing you can ask yourself, what would these two angles be? Because they have to be the same thing. And all three angles have to add to be 180. There's only one answer that they could be, that they are the same thing. So what same number adds up plus 90 to equal 180? And you should come up with 45. So if it's an isosceles right triangle, you're going to have two 45-degree angles. It could be a 45, and a 90. It just has to be, because that's the only numbers that will add up to be 180. And you have two of the same when you have a 90-degree angle. The scalene could be anything, though. It could be 20 degrees and 70 degrees or whatever. So we're going to go through our constructions. So we're going to take this right angle, a hypotenuse, and a leg, and we're going to construct a triangle. Just like we did on the other lessons, we're going to try to construct them differently and see if they have to be congruent. So we need to get our right angle. Let's start with that, because making the angle has to be done first. It works out easier. So you can either copy that angle, or you can try to construct a perpendicular line. I think copying the angle is going to be easier. That's what I'm going to go with. If you didn't have a right angle to copy, you'd have to construct a perpendicular, which means you'd have to do like that football construction to get the perpendicular. But we have a right angle, we're going to copy it. So copy an angle, you make your arc. Then you go to wherever you're going to copy it and make that same arc. And make sure that it goes at least 90 degrees so that you can get your right angle copy. Then measure how wide that opening is. And we need to duplicate that length. And then draw the line that goes through the right angle. And then put your little marking there so you know it's a right angle. So then we're going to copy one of the leg onto either one of those sides. It doesn't matter which one. So measure out the leg. And then you can either draw it along the line we just drew or the line that was there to begin with. Either way is fine. You're going to measure it out from the right angle. So that's how long our leg is going to be. And then we're going to put the hypotenuse on there. So measure out the hypotenuse with your compass. So we're going to put our hypotenuse on there now that we got it measured out. Put it from the leg we just measured. And we know our hypotenuse is going to go kind of along this direction, which means it's going to cross. That's going to be our third point. So we've got our right triangle constructed that way. We're going to do the same thing again. We're going to see if we can make it different though. So we'll start with our angle again. This time let's put the angle on the right side, see if it makes a difference. So we're still going to put it at the point, but we're going to put it on the right side. So you start with an arc that's going to touch both sides like that. And we're going to copy that arc where we want the angle to go. Want the angle to go right here, so copy that arc. And make sure you go at least up to the 90-degree mark. Come straight out of there. Then measure that spread. Right about there. And we're going to duplicate that. From where the arc hit. To the 90-degree spot. So there's our 90-degree angle. So then we're going to measure the leg again. You could, same as before, you could put the leg along either side, the line we just drew or the line that has the arrows on it that was there to begin with. Doesn't matter. It's whatever you want to try. So there's our length. I'm going to put it on the line we just drew this time, just trying to make it different. I don't know. So it's going to go up to there. So what we just did is we marked that length. Those have to be the same because we measured them from that same red leg over here. Now we're going to do the hypotenuse. And we'll do the same thing that we did last time. We're going to go from this point, and we're going to see where it would cross the other side. It'll be over there. So my triangles are overlapping, but there it is. If we trace it, I'll take this highlighter right here. Trace out our right triangle that we just drew. Or if you had tracing paper, you can do the same thing. You could trace it and then see if that matches up perfectly with the original one. So I got to rotate it just a little bit, and then I can translate it up there. Rotate a little bit more. And it's pretty accurate. We've got the sides match up, the lengths are going to match up, the 90-degree angle is going to match up. It does create right triangles. And that's what we call HL. It does create right triangles. So if you looked at just the markings that we have on there, we've got two sides and an angle. Here's our other side. Now match up with this hypotenuse right there. We've got two sides and an angle. So the angle is not in between, so there'll be side-side angle, congruent to side-side angle. And if you remember, we talked about how side-side angle doesn't work. It only works when that angle is a right angle. That's why we don't call it side-side angle. We call it hypotenuse leg, because then you have the hypotenuse and a leg from the right angle. Since it only works if it's a right angle, we give it a special name. So I think we already talked about this, but if you have two congruent sides, that means you have two congruent angles. Are the triangles congruent? So we're looking to see, is this one of our old things? Side, 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 angle, 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 side. Is it one of those? Or is it HL? So if you see a right angle, it does not mean automatically HL. Doesn't mean automatically HL. You still have to have the hypotenuse marked and the leg marked. So this one, we've got a right angle. Did they mark the hypotenuse? Remember, hypotenuse is always the one across. It's the slanted one. They did not mark the hypotenuse, so it's not HL. We've got two sides, and we have the angle in between. That's called side angle side. Still called side angle side. It doesn't matter that it's a right angle. Here we've got a right angle. And then we've got a side. Again, they did not mark the hypotenuse, so it's not HL. It can't be HL without the H. So we do have two angles, and we have the side that is in between. That's angle side angle. There's another one. We've got a right angle, but again, they didn't mark hypotenuse, so it can't be HL. Instead, we've got two angles, and the side that's not in between, we all know that is angle, angle, side. And then for D right here, they did mark the hypotenuse. And we've got a leg on the right angle. That would be like side, side angle or something like that, if that was a thing, but it's not. We got the right angle, hypotenuse, and the leg. Oops. All right, we're going to complete a proof, a flow proof. So we know perpendicular. The first thing we do every time we have a proof is we mark up the picture. So AB is perpendicular to DC. AB, DC. If you need to highlight them to see it, highlight them so you can see it. They're perpendicular, which means right angles. Which means we've got a decent chance that this is going to be an HL. Number one, because we just learned it. It makes sense to practice what we just learned. Number two, we got a right angle. So as long as we get the hypotenuse in there, that's probably what's going to happen. We also are told AC is congruent to BC. AC congruent to BC. There's our hypotenuse. What else do we have? Just from the picture. Reflexive, right there in the middle. Both triangles, the left and the right, they both have that side DC. So this one works a little bit different because normally we do this and write out the letters for the congruency thing that we're going to be using, the Congruence Criterion. Well, there's only two. You have to know three things. So the third thing is it has to be a right angle. That looks weird. So in order to have a hypotenuse, the triangle has to have a right angle. So you have to have a right angle and then say the hypotenuse of one triangle is congruent to the hypotenuse of the other, and then the legs are congruent also. So do we have right angles? Yeah, right here at angle D. ADC. Now, they are technically congruent, but we just need to say that they're right angles. ADC, and if we start with A, we got to start with B to keep them in corresponding order. Those are our right angles. Then you have to name the hypotenuse. AC is congruent to BC. And then we have to name the leg, the reflexive side right here in the middle. DC is congruent to DC. It wasn't rotated around or anything, so you keep it the same order. So that's the information we're going to get to before we prove the triangles are congruent by HL. So we know our last box in the flow proof. The triangles are congruent because of HL. We know that one. We just figured that one out. And then since we know we've also got this little picture thing, from the picture, you only get two things, reflexive or vertical. In this particular proof, it was the reflexive side, BC or DC is congruent to DC. So that's our reflexive property. The hypotenuse was just given to us flat out. It said AC is congruent to BC. That was given. That was our hypotenuse. Which means these two boxes, you had to start with the given. AB is perpendicular to DC. And that's going to flow because perpendicular means you get right angles. So those are right angles because that's what perpendicular means. ADC and BDC are right angles. So, like I said, it's those three things you have to show. You have to show right angles, and then you have to show hypotenuse and leg. So there's still three things, just like all the other proofs we did.